pinball wizard there. All right, so I'm going to run through the information on 7.3. So we're starting to get into sets and building towards some probability. So the first thing I'd like to look at is this addition principle for counting. I want to explain how this formula works with a Venn diagram. All right, so what this is saying is you have two sets, and these two sets, A and B, the union. So this part right here, of course, is saying the union of the two sets is going to be the sum of the members in two sets minus the intersection between those two sets. So let me explain how this formula works in this Venn diagram below. So this one right here says you have two sets. These are people who are buying hard copy books. These are people who are buying Kindle books, the online, and available in both. 12 people have both hard copy. It's available both in hard copy and in a Kindle book like that. So the first thing you got to understand is that this first set, and I'm going to just call this H for hard copy and this K for Kindle, well, that set H contains 18 plus 12. So it has 30 in that set. And then this other set right here, the Kindle books, it's 12 plus 15. So that is going to end up being 27. So when you read a Venn diagram, you got to understand that 18 is not the whole set. It's this little slice right there. All right. So if we were to go through and do this, now the union of these two sets would be this. Now I'm going to have you write this down here. So when we put this together, the number of hard copy books like we would get would be 30. The Kindle books would be 27. The intersection is going to be 12. Okay, and that's given like that. So let me show you how this formula works then. All right, so first of all, the union would just be 18 plus 12 plus 15. And then the number in set H is 30. We figured that out. The number in K, the Kindle books, is 27. And then we subtract off the intersection right there and do that. So if you were to work that out, here's basically what would happen. If I do 30 plus 27 minus 12, that should give me 45. And let's see if this isn't the same. Okay, so if you add 18 and 12 is 30 plus 15 is 45. So it works. Okay, so that's how that formula goes. Now the question is, why does this formula work? And one thing that you want to understand is we've really counted that 12 twice. When we do the 30 and 27, we've counted the 12 twice, so we have to subtract it so that we're not counting it twice. Okay, I hope that makes sense to you. That thing gets counted twice, so that's the reason that we subtract the intersection. Okay, so I'm going to have you go down and try this next one. C is the cats, D is the dogs. Now these are pet owners, I assume, so you have like 5 people who own both cats and dogs and so forth. So go ahead and pause the video and see if you can get everything filled out on this and see if you understand that formula. Okay, so check and see if you got it right. So first of all, the number of owners who have cats, there's 15 cat owners. Dogs, there's 12 dog owners. 5 have both a cat and a dog. So we expect the union of these sets just to be 10 plus 5 plus 7. Just ignore the 8. The 8 would be people that don't own a cat or a dog, okay, in this set. So anyway, it works like this. You do the number of cat owners plus the number of dog owners minus the number who have both. That gives 22. And that's what the union is, okay? All right, and again, from this diagram, make sure that you understand that this thing gets counted twice. That's why you gotta subtract one off. Okay, now going to this next page, gonna fill this out. in kind of a table format like this. So what I'm going to do on this, first of all, is we're going to organize the information into a table to begin with, and then we'll answer these questions about that. To me, it's just as easy to go ahead and do the table, first of all. All right, so what we have is, it says a survey of 100 families found that 35 subscribed to web films, 60 subscribed to Nile Prime, 20 subscribed to both. Okay, so that's enough information to get everything figured out. We could actually make a Venn diagram on this too if we wanted to. All right, and that might help you to put this together a little bit better. So what I'm going to do is we're going to make a Venn diagram just at the side here. Okay, so like magic appears my Venn diagram here. All right, so what I wanted to show you was how we can take this information, fill out the Venn diagram, and show how this relates to this chart. First of all, what I'm going to do, I think I'm going to go ahead and let's do the Venn diagram, and then we can answer these questions and then do the table, because you want to know how to do both methods then. All right, so if we read on this, what we're going to try to do in our Venn diagram, we want to figure out that number there. That would be the people who subscribe to web films that don't subscribe to Nile Prime. This would be the number of people who subscribe to Nile Prime who don't subscribe to web films. This would be the number who do both, and then that would be the leftover, the people who don't subscribe to either service, okay? So if you read on this, okay, first of all it says 35 subscribe to web films. So we got 35 for web films, 60 for Nile Prime. And that's total now. And then the key thing it says is 20 subscribe to both. So that 20 goes there. All right, so it's actually real easy to figure out the rest. So 35 total here. So what would end up going there is you would just do 35 minus the 20 to get 15. So there's 15 people who subscribe to web films but don't at the same time subscribe to Nile Prime. Okay, and then this one, there's 60 total in this circle, so you do 60 minus 20 to get 30, what, 40, oops, okay, so we got 40 there, and then what goes here is this would be, remember we have a total of 100, so first of all you would have to add these numbers up. You would have to go 15 plus 20 plus 40, so that's going to be equal to 75. Then there's 100 families, so you would have to do 100 minus 75 to get the leftover 25. All right, so that's how you figure all that out. Now, you're going to be doing this all the time as we go through this information, so it's important to be able to take a word problem and figure out those four numbers and know what they mean. Okay, and notice on this, if you add these numbers, if you did 15 plus 20 plus 40 plus 25, that gives 100. Okay, so you can kind of add those all up and make sure that you understand that. All right, so part A, what part A says is how many families subscribe to web films but not Nile Prime. That would be the 15. All right, and then how many subscribe to Nile Prime but not web films? That would be the 40. And then it says how many do not subscribe to either? That would be the 25. So you want to know what all those things represent. So a Venn diagram's a real good way to visually figure this stuff out. That's what I recommend. Now as we put this together and begin to fill out the numbers here, first of all, what happens on this, so this says you're a subscriber to web films. Okay, so it says that there's a total of 35 families that subscribe to web films. So that goes there. And then it says there's 60 families that subscribe to Nile Prime. So here's the subscriber there. The total is 60 there. Okay, and then basically it would go like this. This would be a subscriber of both. You subscribe to web and in at the same time. So that would be the 20 there. Okay, and then from here we have a grand total of 100. So that would go there. So basically, this row should add up to 35, that column should add up to 60, and then if we fill in the rest of this stuff, we should be able to do that then. So it goes like this, all right? So 20 plus 15 is 35. See, that's what that number is there. 20 plus 40 is 60. So that's that number there, all right? And then this right here would be 35 plus 65. If you add that up then, so you would end up having that. And see, this would be, if you do that, this number right here would be 60 plus 40, would give you the 100 like that. This number right here would be 65, and then this number right here would, whoa, I made a mistake in there then, didn't I? Oops. Yeah, I'm okay. All right, so the 15, this number right here would be 25, and then 40 plus 25 would be 65. So the numbers have to kind of jibe a certain way. So 20 and 15 gives that total of 35. Okay. If you look at this column, that's the 20 and 40 that give you 60. And then the grand total of these is 100. All right. So notice everything adds up. 20 and 15 adds up. 40 and 25 adds up. 60 and 40 adds up. So everything has got to add up row-wise and column-wise. So that's how you put that together. Okay, so now we'll move to the next thing I want to talk about is a tree diagram. So this says you have a coin that is tossed 3 times. How many possible outcomes are there? Well, we know that if you have a coin, you're either going to get a head or you're going to get a tail. We'll just disregard the slight possibility that it could land on its side. That is possible, I suspect. All right, so what I'm going to do is we're going to make what we call a tree diagram. So the first toss, there's 2 things that can happen. We could have a head, H, or we could have a tail, T. Then we go to the second toss, then the same thing that could happen. So we're going to branch from this. Let's suppose that we tossed a head. Well, the second possibility, we could get, again, a head or a tail. If we suppose that we got a tail on the first, then that could be a head or tail on the second toss like that. Okay, then we branch out to get the third toss. Goes like this. Okay, so from each of these 4 possibilities, just branch out again. So that could be a head or it could be a tail. From here, that could be a head or a tail. From here, that's a head or a tail. And finally, from here, that's a head or tail. So what I want you to understand is this tree diagram is going to give you all the possibilities of what can happen when you toss 3 coins. Okay? So basically, if you want to look at the number of possibilities, you just count these branches there. So there's like 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 possibilities there. All right? Well, how do you do this without the tree diagram? Well, there's basically 2 things that can happen. So what you do is 2 multiplied by itself 3 times because there's 3 tosses, and that gives 8. We call that the multiplication principle. So we're going to learn a little bit about that in this section as we go. Now, one thing I want you to understand on here too is, and you don't have to list this right now. I'm going to go ahead and list this, but if you just read from left to right, you would get these possibilities. So you could get head, head, head. You would get head, head, tail. And so forth. I'm going to go ahead and list these. Head, head, tail. Then it would be head, tail, head. Then it would be head, tail, tail. And then going down here, it would be tail, head, head. And then tail, head, tail. And then tail, tail, head. And then finally tail, tail, tail. Okay, so those are actually the 8 possibilities that would happen if you toss 3 coins. So the tree diagram is a methodology that helps you visualize all of the possibilities. Okay? All right, let's move to the next page here and do a little bit more with this. Okay, so this one is similar. It says we have a 4-question multiple choice quiz. Each response has 3 possibilities, A, B, or C. Okay, so we're going to do this like this. The first question, okay, there's 3 possibilities. So let's just put an A, a B, and a C. Now, sometimes these tree diagrams take a lot of room. Then we move to the second question. I'll call that question 2. Well, there's 3 possibilities. So that would be A, B, or C again. And then from this one, it'd be the same thing. We would do A, B, or C. I'm starting to run out of room. And then A, B, or C like that. That's how you get to that question like that. All right. So this is a 4-question multiple. Well, I should have done a little bit smaller thing here. All right. So let's change that to a 3-question quiz. Okay, like that. All right. So yeah, or actually, I'm going to change my mind again. Let's change this to a 2-question quiz. I mean, I want you to understand what you'd have to do is you'd have to branch these out again, and you'd just have tons of branches like that. So let's just say it's a 2-question multiple choice quiz. Well, what we would end up having here is we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 possibilities on that. All right. So without the tree diagram, what you do is there's 3 possibilities. There's A, B, C, and since there's 2 questions, you multiply it twice to get the 9. That's what I want you to understand. So if it was a 4-question quiz, you would do 3 times 3 times 3 times 3. That's 81. Good idea that I changed the problem, huh? Okay. So anyway, what you would get is the 9 possibilities are this. You would get AA. I guess if you were going to randomly just pick questions on this quiz, you'd have AA, AB, AC, or you could go BA, BB, BC, CA, CB, or CC. There's 9 ways to fill out that quiz. Of course, only one of those is right. Okay, so that's why I changed that. And notice if it was a 3-question quiz, and it would be 3 times 3 times 3, so that would be 27. Okay, like that. So that's how you do that. All right, so I want you to go ahead and move to this next problem and see if you can get this one put together. Do the tree diagram, figure out the number of possibilities. You don't have to list all the possibilities. It's a pretty good thing to do. I think what I would suggest we do is just use P for pan, H for hand-tossed, T for thick crust, and then this one you've got the toppings are pepperoni or their sausage. Okay, so go ahead and try to do that. Okay, here's what you should have come up with. All right, so it's going to go like this. You got 2 branches here. You have 2 types of crust, or 3 types of crust. Then you have 2 toppings. So I just let P, H, and T be my variables. Pepperoni, I didn't want to use P again, so I used R. So R and then sausage. Okay, so what you'd have is if you had a pan crust, then you could either go pepperoni or sausage, hand-tossed pepperoni or sausage, thick pepperoni or sausage. All right, so what you would have then is 1, 2, 3, 4, 5, 6 possible pizzas that you can make. Well, there's 3 ways to do this, 2 for each branch, so 3 times 2 is 6. That's the shortcut of how you can do that. And then the possibilities would be a pan pepperoni, a pan sausage, a hand-tossed pepperoni, a hand-tossed sausage, a thick pepperoni, thick sausage. Now this is only selecting a 1-topping pizza like that. So that would be the 6 ways that you could make that pizza. All right? Okay, so let's move to the next thing here. All right? So I'm going to go ahead. I wanted you to go ahead and try this one too. So see if you can put this one together. A little bit more practice with this one, so go ahead and pause the video and see if you can get this one put. Okay, so look over it and see if you got everything right on this. So I highlighted this. You got 3 spins. The first spinner comes up red, blue, or yellow. So I just did red, RB, Y there. The second spin comes up as 2 or 4. So you branch 2 or 4 like that from each of those. And then spinner 3 can come up 1, 3, or 5. So you got to, from each of these, you got to branch out to 1, 3, 5. Okay, like that. Well, if you count this, this would be 3, 6, 9, 12, 15. There's 18 possibilities. The key thing is there's 3 ways to do spinner 1, 2 outcomes on spinner 2, 3 outcomes on spinner 3. So 3 times 2 times 3 is 18. So those things, that's the shortcut. And it's real important because tree diagrams, you don't want to do a tree diagram any bigger than this thing because they get really messy and complicated. All right, so pause the video if you need to get anything corrected on that, but you want to work on making sure you know how to do tree diagrams here. Okay, so we kind of talked about the multiplication principle and basically what that means. So this is just a theorem that comes out of the book, and without going through all the details of this, if you had 2 operations, you just do the number of outcomes in each operation. If you had 3 outcomes, well, then you would do N1, N2, N3. If you had N operations, well, you just keep multiplying those. So this is saying like this, you had 3 operations. So that's like N1, N2, N3. That's the number of outcomes in each operation. So that's what the multiplication principle is. The tree diagram helps you understand that. Okay, so we're going to get away from tree diagrams here a little bit and just kind of work with multiplication principle now on this. Okay, so this says a coin is tossed with number of outcomes of heads or tails. Then a single die is tossed with possible outcomes of 6. Okay, so we're going to say N1, there's 2 things. That's either a head or a tail. N2 is going to be the outcomes on the dice, so there's 6. So what we would do on the multiplication principle is we just multiply the outcomes. So we'd have 2 times 6, so that would be equal to 12. That would be the answer of the problem. See, you don't need a tree diagram to do that, see. Okay. And then the next thing says, example 5, it says a college offers 2 introductory courses in history, 3 in science, 2 in math, 2 in philosophy, and 1 in English. So it says a freshman is going to take 1 course in each area during their first semester. How many courses are possible? Well, it basically goes like this. You got N1 is there's 2 courses in history. N2 would be there are 3 science courses. N3 would be there are 2 math courses that you could take. In philosophy, that would be N4, that's 2, and 1 in English. Okay, now the student is only taking 1 of each. So what you would do is you would just do 2 times 3 times 2 times 2 times 1. Now if you multiply that out, that'd be 6 times 4, so that would be 24 ways to make that schedule. Okay, so what we're doing is we're taking 5 classes, we're picking 1 from each list. So that's how you would figure that out. So 24 ways to make that schedule. Okay, then it says if a part-time student can only afford to take 1 introductory course, then how many selections are possible? So it's different. And so what this one is saying is the part-time student can only take 1 course. So they're just going to take a course. Well, you'd have to figure out how many total courses there are. So you would do 2 plus 3 plus 2 plus 2 plus 1 if you did that. So if you add that up, that's 5, 6, 7, 8, 9, that would be 10. So there's really 10 courses available to choose from. So that student would just have to pick one of the 10. Okay, like that. So that's why you add on that one. All right, so it's a little different approach. Okay, so I'm going to let you try the next 3 problems. So go ahead and work on the next 3. Pause the video and see if you can do it yourself. Don't wait for me. All right. Okay, so let's check this. Now this is easy to do, but you want to really understand how this goes and how you use that multiplication principle. So this one you just basically had, let's see, 5 color choices, 3 choices of transmission, 4 interior types, and 2 types of engines. So what you're doing is you're choosing 1 from each. So it turns out that if you multiply that out, there would be 120 different combinations of getting that new car model. Okay, that's what that is. The next one is pizza. Okay, you can get 3 types of crust, and you can only choose 1. 4 types of cheese, you can only choose 1. 3 sizes, only choose 1. 10 toppings, but you can only choose 1. It's a much more complicated problem if you could choose like 3 of the toppings or 2 of the cheeses. Okay, that kind of thing. But what you do is just, there's 3 crusts, 4 types of cheese, 3 sizes, 10 toppings. So if you multiply that together, you get 360. By the way, how I did this, I can do this in your head, and you should too. 3 times 3 is 9. 9 times 4 is 36. 36 times 10 is 360. Don't just rely on your calculator all the time. All right, so the next page, and you get a real big number on this one. So, and this is like a password. And if you're trying to come up with a combination or something like that, the more outcomes you have, the less likely somebody is to break the lock or pick the lock or whatever. So basically, this just says you're choosing, you have 5-character password. So I mean, one possibility would be A, B, C, D, E. Okay, that's not a good password to pick, probably. All right. Well, the idea is there's 26 letters in the English alphabet. Okay, so we would just do 26 and multiply that out 5 times. That's the same as 26 to the 5th power. Now, this one I did on my calculator. So I got 11,881,376 ways to come up with a combination lock. Okay? For instance, I wanted to just kind of mention what I have, like on my door to my home, it has 4 digits. So let me just kind of do something here. So basically, it has digits. Well, there's 10 digits, 0 through 9. So basically, if you did this, if you did multiplied that out, 10 to the 4th, you would get 10,000. So there's 10,000 ways that I could have created my password. But I like the 11 million a lot better, okay, than the 10,000. But still, there's only a 1 out of 10,000 chance that somebody's going to pick the right combination that I chose. All right, so it's possible, somebody could break the lock if they just tried all those things, all right? Okay, so let's move on to this last example. All right, so I'm going to get going on this one. So this one says a small combination lock has 3 wheels, each label with digits 0 to 9. So this first thing says how many 3-digit combinations are possible if the digits can be repeated. Now that's very similar to what I was showing you over here. So you have a 3-digit combination. Okay, so you just basically got this, and you can repeat digits. What I mean by that is you could have 999 could be your combination. You might have 992. It just says you can repeat the same digit. So that would mean there would be 10 possibilities there. Now you can use any of the 10 there because you can repeat, and then any of the 10 there. So you would just do 10 times 10 times 10. That's 10 to the 3rd power. So that would be 1,000 ways to do that. Okay, that just means you can repeat. Okay, now the next one is a little bit different situation. This says digits cannot be repeated. All right, So you got to understand what's meant by that. So what I'm going to do is just kind of put this together. I'll draw my boxes kind of like this. Okay, so here's what happens. The first digit could be anything. Okay, but the second digit, you can't use whatever you use there. Okay, so you would have to throw out whatever you chose there. If you chose a 9, you can't use it anymore. So that means there would be 9 things left over. All right, so let's say that you got like the first one, let's just say the first thing was you picked a 7. Well, you couldn't pick a 7 then. Let's say, well, the second time you picked a 6. Well, when you get to the third choice, you can't use a 7 or a 6 because you can't repeat. So now there would be 8 things left over. Okay, so then you would multiply those things out. So if you do 9 times 8, 72 times 10 is 720 ways. So if you can't repeat, that's a little smaller. Okay, so that goes like that. All right. The next ones I think is the hardest one for students to understand. This says successive digits must be different. So what you have to eliminate, so for an example, if you picked a 7 there, you couldn't pick a 7 there. But you could pick like something different like a 5, but then you could do the 7 again. That would be okay. Now in part B, this would not be okay. But in part C, it is okay. All right, so it just says ones next to each other must be different. So something like 775, you can't do. Or something like 755, you can't do that either. So you have to understand what the meaning of this problem is then. Okay, so let's draw our boxes. And we've got a 3-digit code like this. Well, the first time we can pick anything, so that's 10. The second time, okay, like this 757, we couldn't use the 7, but we could use anything else. So there's 9 possibilities. Now here's where it's a little tricky for students. Okay, remember if you look at this possibility, okay, we have 7, 5. Now we could use anything except the 5, because we can't have that. So there would be 9 things left over. You got to think about that one. Anything on the first. Anything but 7, I'm just using this specific example to help you understand that. Anything but 7, okay? When you get here, it's anything but the 5. All right, so if you did that, 9 times 9 is 81, times 10 would be 810 ways like that. That's tricky. You got to think about that a little bit. All right, so pause if you need to, otherwise I'm going to have you go down to the bottom of the page and wrap this problem up, then that'll be the end of the section. All right? Okay, so let's figure this out then. And, I was thinking about license plates. Somebody's got to figure this out. I mean, you can't, if there's a certain number of registered vehicles, then somebody's got to figure out how many ways there are to make license plates. So these are real big numbers. On these things then. So what the way it happens is like this then. All right, so this first one is, I have a problem here. Hold on. I'll show you what I saw. This is wrong. How did I catch my mistake? Well, I suspected this would be smaller than this. That's pretty clear that's smaller than that. I saw 17 million and 44 million. I typed the wrong thing in my calculator. So let me do that again real quick. 26 times 25 times 24 times 10 times 9 times 8. I always try to catch mistakes when I can. I don't always do that, but sometimes if you just think a little bit about your answers, sometimes you can catch little things like that. So that your answer should be this. That's more logical. Okay. So it goes like this. You can repeat. So this one, there's 26 letters. You can use any of them. So just 26 each time. Digits, 10, 10, 10. You can repeat. So in other words, you could have a possible license plate could be YYY 111. Okay, like that. All right, that's okay. Now this next one, so you multiply that out, you get 17,576,000 ways. So that's how many license plates that are different that could be made. This one you can't repeat. So 26, 25, 24, so you could have A, but you couldn't use A again. You could have, you couldn't use A or B, so you could have C. And on the digits, maybe you could do 9. Well, we could go like this, okay? I'm thinking of something here, okay? 1 and then 2, 3. A, B, C, 1, 2, 3. Okay, there's a song from the Jackson 5. A, B, C. So maybe that was one of the Jackson 5's license plate then. So anyway, it would go like this. So you would get 11,232,000 like that. If you don't know that song, YouTube it and look it up. It's a funny song. Okay, I think it was a #1 hit like in 1970 when I was a kid. Okay, so that'll wrap that up, and hopefully that'll help you learn how to do this information. It's not that hard. Easy for me to say.